Hello, AP Chemistry students, and welcome to your summer homework again, Unit 3, Lesson 1, which is going to be all about the atomic scientists. So let's first start off with Dalton. Dalton's experiments led to his discoveries, which were the following: that elements are made up of identical atoms which cannot be created nor destroyed. They can combine to form compounds in whole number ratios. And chemical reactions involve the breaking or creating of bonds, but never changing elements into new elements. So these are the three main things that Dalton's experiments led to him discovering about the atom. J.J. Thomson's the next one. This one you should know very well. You should be able to recall what his model of the atom looks like, but we're going to go over it. He discovered negatively charged particles called electrons using the cathode ray tube. So what he did is he had gas that was in this cathode ray tube. He put a voltage through it. There was a negative plate and then a positive plate. Then he had magnets on either side of it. And what would happen would be that that stream or beam of light would go towards the positive plate, which meant that it was bending. And then when he held the negative plate up close to it, it would bend away from it. So that led him to believe the following. So he constructed the Plum pudding model, which basically said that there was a positive charge of stuff or a cloud, and then there were negatively charged electrons throughout. He assumed that there was a positive charge since the atom had to be neutral. If the electrons are negative, you have to have something that's positive to counteract that negative-positive attraction. Next, we had Rutherford. Rutherford shot high-speed alpha particles, which are helium nuclei, at the gold foil, believing they would be deflected. Some were deflected, but then he discovered, because some were deflected, that there was a dense positive nucleus where we now know the protons and neutrons are stored. So some of those alpha particles hit that nucleus dead on, which had them reflect back. Some of them also went straight through. So Rutherford was the one that came up with the fact that the nucleus holds 99% of the atom's mass. So he discovered the dense positive nucleus, and he also discovered that since most of those alpha particles went straight through the gold foil, that most of the atom is also made up of empty space. So here's a close-up look. Most of those alpha particles went straight through, but we also had some that hit something that was positive. So that meant that since alpha particles are positive, they had to have also hit a positive nucleus. So most of the alpha particles went through, so then he thought, again, that the atom is mostly empty space. So his model of the atom is on the right here. He created the nuclear model of the atom because he's the one that's being known for discovering the nucleus of the atom. And then the final person we're going to talk about is Niels Bohr. He took Rutherford's model and then kind of went above and beyond with it. Rutherford's model couldn't explain why electrons didn't collapse into the nucleus. Since electrons are negatively charged and the nucleus is positively charged, you think that the electrons would fall close to the nucleus because they were highly attracted to each other. Nucleus being positive, electrons being negative. And Rutherford's experiment didn't explain why that didn't happen. So Niels Bohr didn't like that. So he proposed that electrons move in specific paths, which we call orbitals, and they circle around the nucleus. So here is his picture of the atom on the right. You have your nucleus in the center, then you have your electron orbits around the outside, and he discovered that energy can either be added or removed, which will force the electrons to change orbitals, and when those electrons fall or get excited and then fall back to the nucleus, they release that energy that they were given to make them jump to an orbit that is further away from the nucleus. And when they fall back down, that's when they produce the light. And that's how we get the Roy G. Biv spectra of light.